I had to take a small mental break, reset myself. I was out of it. Didn't get enough sleep. Anyways, back to 17. Use a graph to solve 1/2 of the absolute value of x minus 1 plus 2 is equal to the absolute value of x. So the form here is a times x minus h plus k. So I'm going to go right 1 and rise 2, opposite trust. Absolute value is basically a linear function, so you can trust that 1/2. It means to rise 1 and run 2. That's what she means. You can only do it with things that are linear, that you can actually use the slope like that. You're supposed to rise 1/2 and run 1. But if you do that, you get the same thing because these are linear. Absolute value is still a linear function because trapped inside absolute value is 2 lines. So we still have the same concepts of somewhat being slope. And there is first the left-hand side of your equation. The right-hand side of the equation here is just the absolute value of x, which is just a v that rises 1 and runs 1. I should have extended this one out a little farther, shouldn't I? But as you can see, there are 2 intersections. There's an intersection there and there's an intersection there. One of your intersections is at x equals 3. That is a solution. Or the other one's way back here. If we just look down at the x-axis, x equals -5. You know, you have to actually show me the graph on your test. You do. And there's no issues about it. You're going to have access to your TI-84 or to my TI-84, whoever's TI-84 you have. And you know, if you got 10 extra minutes or 2 or 3 extra minutes, you'd be an absolute fool if you didn't check your work. You go to math, you go to num, n over d. That'll let you open up the fraction bar. Math, num, because that's how we all feel right now. X minus 1, arrow out, plus 2. And in y2, math, num for absolute value, x, zoom, 6. You'll see the same thing I just drew. And you can check your work here, make sure your intersections are right. Second trace 5. Get the little blinky dude close, and once she is close, enter, enter, enter. There's that 3 I was telling you about, second trace 5. Scroll to the left this time. The little cursor somewhere over there, and she is. Enter, enter, enter. -5. All right, 18, use a graph to solve twice the absolute value of x plus 2 minus 3 is greater than or equal to 0. This is also an equation. This is y equals 0. That is this right here, all right? That is the x-axis. This thing is saying where or what values of x is the graph above the x-axis. That's all it's asking you. So we see this thing would go down 3 and left 2. And it would rise 2 and run 1. And it would look like this. And those little points right there are incredibly important. The ordered pair here is -3.50, and the ordered pair here is -1/2, 0. And you're above the x-axis on this tail and this tail. In other words, you are above the x-axis from -infinity all the way to -3.5. And we have equality there, don't we? The bracket. Sorry, I forgot the bracket. And union with -1/2 to positive infinity, because this side, as you move right, that's interval. Or it could be written out such all values of x such that x is less than or equal to -3.5 or x is greater than or equal to -1/2. Doesn't really matter how you write it. That's 18. And there's only 2 left. And I can be done with doing math and start grading some math. Yay. Solve the system of equations algebraically. This is a core Algebra 1 standard. It's called the substitution property. I can take the first equation and in one swift move, I can solve it for x. It's 15 minus 4y. Then I can take that and I can put it right there. That's what I do. It's called substitution. 2 times 15 is being 30. 2 times negative 4 minus 8y. Shift things around. This one's got a fraction answer, doesn't it? That's really surprising. Oh, that's what's wrong. Forgot the minus y. I just shouldn't be doing math this morning. Minus y. There we go. Negative 9y equals negative 45, and my y value is 5. Now all I got to do is figure out the x value. I know that x was, from a previous operation, 15 minus 4y, so I'm going to plug that 5 in. And 15 minus 4 fives is going to be negative 5. So I've got this ordered pair, negative 5, 5. That's my answer. And 20 is a use technology problem. Use technology to solve the equation negative 2 absolute values of x plus 3 equals a quarter x squared minus 3. And I just made this thing up a few minutes ago, so let's see what it looks like. There should be two answers. We should see an upside down v that's got a pretty steep slope and a pretty wide parabola, because that 1/4 out front is going to be a vertical compression, which makes it wider. So let's see. Negative 2, math, num, absolute value, x minus 2, plus a 3, math, num, n over d, 1 over 4, x to the second, minus 3, zoom, 6. And there are two answers. I had a hunch there would be. So second trace 5. I'm going to go after the left one here. Enter, enter, enter. There's your x value. I know it's kind of hard for you to see at home, but one of your x values is about negative 0.8990. It says round to the nearest 10 thousandths. So after that 9 is a 7, which makes this a 0, which makes that a 9. Rounding, kids. The other x value is over here, second trace 5. Take my little cursor dude, get it close, press enter 3 times, and here's my other x value. I'm calling them x1 and x2 for no good reason. 3.4833. Ta-da! All right, there's that. Now I get to go make copies of everything so that you may have it, and I can give it to you on Friday and just kind of like ruin your day or something.